Hi, this is Grant coming to you from my porch in East Oakland. AI has or is taking control over more of our everyday systems, our interactions, societal decisions, even our phone helplines. So, understanding the authority of algorithmic governance becomes more and more important to hold on to some sense of identity and autonomy in our lives. To understand algorithmic governance the way we experience it today, we actually need to look way back to the 1700s. This is when the idea first took hold that machines running algebraic equations could and should make decisions to rule our society. The sci-fi trope that machines control us and that the world we live in is controlled by computers, such as The Matrix, Tron, Westworld, etc. These have roots in the philosophizing of Leibniz. Since that time, the logic and equipment needed to fulfill that idea has been progressively and steadily created. It's been improved on. And that brings us to this very day in which we are almost over the threshold of artificial general intelligence. That means that the thinking machines that have haunted the human psyche for a century are almost here. However, even with all this modern sophistication, the astounding technological invention, the philosophical bedrock of all digital technology actually remains unchanged. The binary code baked into the circuits of computers is rooted in the very limited 1800s morality that George Boole called in his book, The Laws of Thought. His extremely reductionist, formulaic approach to human knowledge is a highly limited imagining of how humans actually think and make decisions. Despite these extreme limits, every operation in every digital computer since they were invented is guided by Boolean logic, no matter how complex the machine is or the task given to it. This also includes quantum computers, which work by translating to and from binary code for human interaction. My main point here is the logic used to create and program computers is far from neutral. Relying on this mechanized reductionist formula binds us to a very problematic 19th century way of thinking about the world and our individual place in it. It ignores the fact that every circumstance in our human lives is nuanced, it's unique, it's unable to be accurately described like an item in a shopping list. We're already being dishonest with ourselves by accepting the reduction of our existence to a simple yes or no definition. Nonetheless, our entire civilization has attached itself to this simplistic moral code. Back when I was a master's student in Toronto, I researched this code and the values behind it. As time passed, rather than falling into irrelevance, this research has become more and more pertinent with our always increasing dependence on digital technology. So I've made this video here to help us all better understand the philosophical roots of our current relationship with technology by looking at binary code as the primary text that informs the digital logic behind every moral decision that's made in algorithmic governance.
We increasingly delegate our most complex decisions to artificial intelligence. We assume computers are neutral, objective, calculating tools. This assumes the language underlying this power, binary code, represents an objective law of nature. But the ones and zeros that make up binary code are a highly specific cultural artifact. The binary strings used in modern computing function as a subjective, human-authored text. When we ask an algorithm for an answer, we are submitting our questions to an antique human ideology encoded in mathematics.
The pixels on your screen are actually hiding this massive, highly opinionated philosophical engine built directly into the hardware itself.
This text carries specific epistemological values that dictate how the machine organizes reality. To understand the cognitive architecture driving modern AI, we have to look past the server racks and trace a 300-year-old mission to mechanize human thought. Failing to recognize the human authorship behind these algorithms leaves us following a rigid set of rules we never actually agreed to. The blueprint for automated reasoning begins in the 17th century with Gottfried Wilhelm Leibniz. He proposed that all human concepts could be reduced to a precise alphabet of mathematical symbols. Leibniz believed that if complex moral and political problems could be computed, astronomers and thinkers would be freed from the slave-like labor of calculation. He built this machine to prove that reason could be a mechanical process. This ambition was rooted in his philosophy of monism, the faith that the entire universe operates under a divine, rational order.
He basically believed the entire universe was made up of infinite, self-contained, indivisible units called monads, and they were all just executing this divine, perfectly harmonious plan. But crucially, Leibniz envisioned mathematics and calculus as this ultimate, universal language that could perfectly calculate the truth about life and the universe.
He believed every aspect of existence could be categorized, quantified, and computed. Under this framework, physical reality and human nuance are treated as fallible distractions. For Leibniz, the only reliable path to understanding the universe was through calculation. This set a historical expectation that persists today. The idea that human reasoning is inherently flawed, and that we should outsource our judgment to an infallible machine. In the 19th century, George Boole translated Leibniz's abstract ambition into a system of algebraic laws. Boole's system uses the operators and, or, and not to perform deductive categorization. This logic requires a finite environment. The math cannot process the infinity of the natural world. To make the system work, the author must use arbitrary closure, drawing a hard boundary around a dataset and treating that box as the entire universe. In this system, the universe within the box is assigned a value of 1. Anything outside those boundaries is assigned a value of 0 and is treated as non-existent. Boole argued that these algebraic signs revealed the inherent laws of reasoning. He believed he was formally documenting the biological mechanics of how the human mind works. By defining logic as a calculation, this algebra ensures that anything that cannot be reduced to a 1 or a 0 is effectively filtered out of the machine's capacity to process it. The decision of which variables to include inside that box is a subjective human choice. These initial categorizations reflect the cultural values and specific biases of the person designing the system. Once these boundaries are established, the system processes the restricted data with a blind internal consistency. Mathematical perfection within a computer is made possible by the human intent that artificially constrained the reality it measures. In 1938, Claude Shannon demonstrated how to translate Boole's closed-universe algebra into physical electrical engineering. Shannon used electrical relay switches to manifest the abstract logic of and, or, and not gates. Shannon showed Boole's logic could be executed by electricity. A true statement became an electrical pulse, while a false statement became a pause. Shannon's design moved Boole's subjective logic from the page and into the physical architecture of the machine. John von Neumann expanded Shannon's circuits into the foundational architecture used by every modern electronic computer. The first machines capable of running this binary logic required entire rooms of hardware and operators to manually set the switches. Glass vacuum tubes served as the physical placeholders for these binary digits. They stored the ones and zeros as tangible electrical charges. The 17th century philosophical desire to calculate truth had successfully moved from paper into the physical behavior of electrical pulses. The hardware reinforces this logic, as it can only recognize the electrical presence or absence defined by human categories. The hardware enforces a binary logic of presence and absence, making it a physical manifestation of Boolean reduction.
Boole said, the operation which we really perform is one of selection according to a prescribed principle or idea. This is the concept of arbitrary closure. Human intent must forcibly reduce the infinite chaotic universe into a predefined list of known possibilities. The machine only comprehends the specific, arbitrary categories we have explicitly chosen to put into its system. Digital reductionism forces reality into a rigid yes or no, a 1 or a 0, but human induction, we get the joke, we understand sarcasm, we can read the room, we understand context, gray areas, and really subtle shifts in meaning.
Reduction works by stripping away context and nuance until a concept fits into a discrete variable. This process stands in contrast to human induction. Induction is the capacity to synthesize vast, unquantifiable analog experiences into wisdom. Binary logic is purely deductive. It is blind to the spaces and contexts that exist between its discrete variables. Computation relies on deductive reduction, making it an inadequate tool for representing the full spectrum of human existence. This reductive logic now underpins the massive algorithmic systems used to manage modern society.
Let's ground this high-level philosophy with a candy bowl analogy. Imagine a big bowl filled with a totally random assortment of candies and chocolates. If you use Boolean logic to search for items that are red and candy, the system is going to retrieve the red candies, but it will automatically, blindly ignore the chocolates. Why? Because chocolate wasn't a defined variable in your search. Boolean search parameters are incredibly effective, but they rely on an arbitrarily closed environment to function. If it's not in the database, to the computer, it simply doesn't exist.
Because of this massive structural limitation, there is so much that binary code and digital reductionism completely fail to represent in our society. It struggles to capture morality. Think about the incredibly complex ethical dilemma of a self-driving car in a crash. It cannot capture human intuition. You know, that gut feeling you get that a business deal is bad, even if the numbers look good on paper? It completely misses subjective emotional states. An algorithm cannot genuinely comprehend why a flagged photo represents grief rather than a policy violation. And it really struggles with continuous change, since binary code requires freezing a moment in time just to process it as data.
The devices we use today are locked into 19th century rationalist rules. Artificial intelligence does not generate meaning or understanding. It executes the parameters of this embedded philosophy, sorting and correlating data through rigid binary filters at extreme speeds. This explains the difficulty of digitizing common sense.
We can see this failure super clearly if we walk through the information hierarchy. Let's say you see the number 1, 2, 3, 4, 5, 6, 7. Standing alone, that is just data. When the computer tells you your bank balance just jumped to that number, that becomes information. But knowledge is your totally human realization, wait a minute, nobody owes me that much money. And wisdom is your conclusion, I should definitely talk to the bank before I spend a dime of this because this is obviously an error. Computers can process massive, absolutely unimaginable amounts of data and information, but they are structurally incapable of human knowledge and wisdom.
True wisdom requires lived experience, an analog process that cannot be expressed discretely in a string of code. When we yield authority to these machines, we are enforcing a subjective, historically bounded value system that prizes calculation over interpretation. By recognizing algorithmic governance as a human creation rather than an objective force, we reclaim the authority to question its output and its history.
Which leaves us with a final, absolutely vital question. The digital world isn't some natural objective phenomenon. It's a deeply human philosophy hardwired into microscopic switches. If binary code is just subjective human logic dressed up and disguised as perfect math, who is actually governing your reality? The next time an algorithm tells you what to read, who you should connect with, or what is supposedly true, take a step back and ask yourself whose values were coded into that specific machine.